In the present video, we will discuss the numerical problem on EOQ model with gradual supply and shortage is allowed. Let's see the problem. The demand for an item in a company is 18,000 units per year and the company can produce the item at a rate of 3,000 per month. The cost of one setup is 500 rupees. The holding cost of 1 unit per month is 15 pice. The shortage cost of 1 unit is 240 rupees per year. Determine first one the optimum manufacturing quantity, second one the number of shortages, third one the manufacturing time, fourth one the time between setups. Let's see the solution. So first to write down the given data. So here it is given the demand for an item in a company is 18,000 units per year. So let's consider demand rate. So capital D or maybe the small d, which is equal to the 18,000 per year. And next it is given the company can produce the item at a rate of 3,000 per month. So it is given the production rate, which is the P equal to the 3,000 per month. So we have to convert the demand rate also per month. So it is given the 18,000 per year, then 18,000 divided by 12. So which is equal to the 1,500 per month. And next it is given the cost of one setup is 500 rupees. So setup cost or maybe the ordering cost C0 equal to the 500 rupees per setup. And also given the holding cost of 1 unit per month is 15 pice. So CH holding cost, which is equal to the 15 pice, which means 0.15 rupees per month. And next also given the shortage cost of 1 unit is 240 rupees per year. Let's consider CS shortage cost, which is equal to the 240 per year, but we have to convert the per month, then it will become the 240 divided by 12, which is equal to the 20 per month. So then first we have to determine the optimum manufacturing quantity. So in the data I have to observe demand rate is given and also production rate also given and shortage cost also given. So this model belongs to the EOQ model with gradual supply and shortage is allowed. First you have to determine the optimum manufacturing quantity. So which is the total manufacturing quantity Q star. We know the formula Q star equal to the root of 2D C0 by CH into P divided by P minus D into CH plus CS divided by CS. So in the data we know that, so D we know, C0 we know, CH we know, P we know, D we know, CH and CS also we know. Then substitute, then Q star equal to the root of 2 into 1500 into 500 divided by 0.15 into 3000 divided by 3000 minus 1500 into 0.15 plus 20 divided by 20. Then solve this, we will get the quantity is the 4488.88 units. So this is belongs to the Q star, that is the total optimized manufacturing quantity. So next we have to determine the number of shortages. So number of shortages is the Q2. So maximum quantity of the shortage. Q1 is the maximum inventory, but here we have to determine the shortage quantity. Then Q2 star. So we know the Q2 star formula, which is equal to the Q star into 1 minus D by P into CH divided by CH plus CS. We know all the values and substitute, we will get the Q2 star equal to the 17 units. Next we determine the manufacturing time. So manufacturing time T1, which is equal to the Q star divided by production rate P. So T1 equal to the Q star divided by P. We know the Q star value is the 4488.88 and production rate is given the 3000 per month. So it is the month wise. Then T1 value which is equal to the 1.5 month. Next we determine the time between the setups, which is nothing but production cycle time. We know the formula, production cycle time. So total time small t equal to the Q star divided by demand rate small d. Then substitute. So Q star value and the d value. So we will get the production cycle time or time between the setups equal to the 3 months. So this is the solution, and thank you.